My name is Raymond Convalius. I am a consultant and trainer from the Netherlands, where I work with companies to advise them on modernizing their infrastructure, and I regularly do meetings with other IT people where I tell them about new technologies and what's currently happening in the market. So let's start with device guard. It was regarded as AppLocker on steroids by Sami Laiho. You probably know him. And there's always been some discussion, is device guard the next version of AppLocker? And how is it being used in the technology? Well, device guard is not AppLocker. Actually, AppLocker and device guard are supplementary. It's not the same technology, and device guard is further down the stack in such a way that it's very hard to circumvent if you implement it right. And it has a lot more requirements than AppLocker. It has hardware requirements that are not there for AppLocker. And device guard will be used both on clients and on servers. I think it will be even bigger on servers than it will be on Windows clients. So, how do you position device guard? Well, first of all, if you look at the security stack of Windows, it starts with the hardware nowadays, where the UEFI is very important, and you have to be sure that no malware is being loaded while you're starting your system. So first of all, there is secure boot, which is now considered part of device guard. Then, after secure boot, device guard comes there, and what device guard actually does, it runs both in a kernel mode and in user mode. What it does is that it checks each and every binary that is loaded if it's signed and trusted. And if it's not signed and trusted, it cannot be loaded. So first of all, it's in kernel mode. All drivers will be checked for the signature. If it's not signed and trusted, it will not be loaded. And then in user mode, the same thing happens. So even in user mode, it's like, well, every binary that you run must be signed. And if it's not signed, it cannot run. And even if it's signed, it must be signed by a trusted company. Otherwise, it cannot be run. But both of these signatures that are being checked by the code integrity policy are checked system-wide. So, for instance, if you allow your system to run Windows Store applications, those are all being signed by trusted entities. And if you want certain Windows Store applications not to be run by your users, then you require AppLocker. So AppLocker can be very handy in those scenarios. But AppLocker, if you're a local admin, you can always circumvent it. So, in short, the differences between device guard and AppLocker are about running user mode and kernel mode. As device guard is checking kernel mode as well. It's very hard to circumvent by the admin. And even an admin cannot always disable your device guard policy. So if you implemented your device guard CI policy and you do it really right, in the right way, then even a local admin cannot change that. And I'll tell more about it later. But it requires specific hardware. So not every kind of hardware is able to run device guard. So as I said, device guard starts with booting your system, booting from trusted hardware, using UEFI secure boot. The UEFI is locked down and provided with signed software before your system is able to boot. And then the code integrity comes in place, and this is actually what device guard is all about. You create a code integrity policy, CI policy, and first of all you create the kernel mode CI policy, and it used to be there before, and it's for drivers, so that drivers must be signed before they can be loaded. And then it comes up into user mode. Now, signed software as a requirement may be something really hard to overcome if you're running a lot of line of business applications and your company is not doing signing of your line of business applications. And in those cases, Microsoft has created another way of dealing with this by creating a catalog. So you can create a catalog file which consists of the hashes of all those trusted line of business applications and sign the catalog file only. And if the catalog file is trusted by DeviceGuard, then you are able to run your line of business applications on a DeviceGuard secured device. To make this all really, really, really secure and make sure that there is nothing running on the system that can tamper with DeviceGuard, DeviceGuard is making use of virtualization-based security. And virtualization-based security is, in fact, running trusted processes in a separate virtual machine. So you have Windows running on your system and you have a separate virtual machine. It's a mini virtual machine with a trusted process, especially for DeviceGuard, that will do the checking for you if each and every binary that you are loading into memory applies and works with the CI policy that you defined. So in that way, no other processes are able to kill DeviceGuard or do something with it because the connection between Windows 10 and the VM that is running the DeviceGuard processes is highly protected. There is no way for other processes to communicate with the DeviceGuard process than Windows 10 itself. Well, so if you want to start working with DeviceGuard, it will require some planning because you first require the hardware that supports it. So it must be hardware that has a TPM 1.2 at minimum, but 2.0 has better security and more possibilities than 1.2. Your hardware must be virtualization capable as well. And if you want to do it really good, it must support IOMMU, which is to prevent you from DMA attacks on your systems. So, and your drivers must be compatible. So you must have signed drivers. You cannot run your systems with rogue drivers or do anything with it. And in the end, there is the option to sign your CI policy. And signing the CI policy, I will talk about it later, it will actually make your systems secure in such a way that even the administrator is not able to change the CI policy. If it's there, and only one person will be able to do it, and I will tell you who that is. So, when you start deploying DeviceGuard, first thing you have to do is make sure that you create the golden system, the system that represents other systems that will be running your DeviceGuard protected software, that will be running with your CI policies. And what you create from the golden system, well, you start scanning it. Create a scan with the signatures of all software that is on there, and it will create an XML. And that XML will be the basis for your CI policy that you will deploy to all your systems that are protected with DeviceGuard. When you have scanned it and you have this first initial XML file, then Microsoft says, well, it's a good idea if certain binaries for Windows cannot run on your system. And Microsoft has created a list of recommended programs that you should not run on a DeviceGuard protected system. There are some names in there that at least raised my eyebrows, like bash.exe, older versions of bginfo.exe, and for instance mshta.exe. What it actually says is if you run those programs, you are probably able to go around, circumvent your CI policy. So what Microsoft does on their website, they have a CI policy ready to copy that you can merge with the initial XML that you just created to create the device policy, the CI policy with all the programs in there that should run and the deny list of a few programs that should not run on your device guard protected system. So you did a scan, you merged it with the recommended programs. Then before you can implement the CI policy, you have to convert it to a binary file. So first you have an XML file from the scan, and the scan can be converted to an XML file. And that's quite a simple PowerShell command that you run. And then you have a binary. And that binary can be applied as being the device guard CI policy on your system. First of all, you will run it in audit mode before you break stuff. And running in audit mode will create events. And you can use the events that are created from running your device guard device in audit mode. You can use those events to actually extend your current CI policy with your findings from what you were doing in audit mode, so that in the end, if you checked and you merged your findings, you can create quite a valid CI policy that contains everything that you are running on your system. But before you start doing that, you have to make sure that your device is ready to start running Device Guard. And to do that, Microsoft has created the Device Guard Readiness tool. So you can download a PowerShell script from the Microsoft website, the Device Guard Readiness tool, and check if it's capable of running Device Guard. And it will check if hardware virtualization, the virtualization-based security can run, and if the CPU is capable of doing everything it should do. And then you get a report, and if you get a green flag, you can start deploying your CI policy. So the deployment steps, in short, first you run the scan. Be aware the scan might take a long time because it will be scanning each and every binary on your system to ensure that it is added to the CI policy. And then you merge the XML that you get with the CI policy that is provided by Microsoft with its recommended deny applications. So that creates something that you can start using. Then you convert it to a binary, and then you apply it. And applying it can be done in two ways. If you apply the CI policy, you have this binary, and you can add it to a group policy. Deploy Windows Defender Application Control, that's the latest name. And what actually happens is that it copies the binary that you created to Windows System 32 Code Integrity SI policy.p7b. That's the file that is being created. So you can do that yourself. If you copy your binary to that file and then reboot your system is running with the CI policy. I'll go back for your picture, but the deck will be downloadable. So now you're running in audit mode. And running in audit mode means that a lot of events are being created while you're running Windows and doing stuff. Because the first initial scan will not catch everything. And when you've done that long enough, you can actually scan the event log to create a new XML file. And then merge that XML file with the XML file that you used the first time to extend it with all the findings, so that you have the good CI policy that you can run and you might enforce if you dare. And before you do that, first prepare for accidents so that you can do an advanced boot in case it doesn't work. You might have missed a certain driver, and if this driver keeps you from booting, you've just broken your system with the CI policy. So make sure that you have a backdoor in the beginning when you are testing. And if you're done testing, Well, you start testing by disabling audit mode and doing the real thing, enforce mode, and then you start running in enforce mode. And if you're running in enforce mode, you have a system that runs device guarded and protected. But still, this is this one single file in your system32 folder that can be removed by any local administrator. Now, what can you do about that? Well, what you can do about that is actually sign the CI policy that you created. And if you signed the CI policy and applied it, there is only one person who can unapply it or change it. That's the person who actually signed the CI policy. So that's not any, if any local administrator removes the file, the CI policy will still be applied. Only if there is a new CI policy that has been signed by the same person or the person that has the private key with the certificate that was used for the first CI policy, then it can be changed. And if you're running this protected system, well, it's system-wide. So everything you allow is allowed for every user on the system. And if you don't want to allow it to every user on your system, then AppLocker comes into place. Then you can filter. You can tell, well, certain users should not run these applications from the Windows Store, for instance. And by doing that, you can make it more granular. But still, if you're using AppLocker, every local admin can run every application that was allowed by the CI policy. So in summary, most standard hardware for today is capable of running device guard because the requirements are not that hard. It must be virtualization capable, must be 64 bits, must have a TPM in there, and then it must have a UEFI to boot from. If you have that, then you have the hardware that can actually run it, but you have to ask yourself the question, should I run it? And that was what this remark from Sami Laiho was about. Should you run device guard on each and every system? Well, if you're running kiosk systems that are really there in a place that can be tampered with, yes, then you should. If you're running an ATM machine, yes, then you should. If you're running a very ordinary business machine, well, maybe AppLocker is just enough for you. So device guard, yes, it brings you much more security, but you should consider if you are willing to go through the pain of implementing it and going through the pain of updating it and keeping it up to date so that it doesn't break at the next upgrade of Windows or any application that you will be running on it. If you want to try device guard, there is a device guard deployment guide which provides lots of really interesting information and helps you to start implementing it. And if you want to see the demos, tomorrow morning, 10:15, there's my extended session, 45 minutes. You're welcome. I will tell this story again, but I will show as well how it works and what it looks like. For now, my 20 minutes are over, so thank you very much for being here. My name is Raymond Convalius. Please fill out the evaluations if you liked it, and hopefully see you soon again.